Hey guys, what do you think is the biggest problem that we as, well, humans would face today if we wanted to travel to the Mars? Write your opinion down in the comments below and your reason to it. Today I'm gonna propose to you which one is which one I think is the biggest problem. So, first off, let's go over the structuring. First off, I'll tell you a little bit all about the problems and the kind of solutions to them. Then, two, I will go further into the one I think which is the largest. Three, I'm gonna add a little bit of math of how to fix that big problem. And four, least but not last, the conclusion. So, let's start with the problems there are. So now, which problem have I chosen for me to, in my opinion, be the biggest one? Well, let's take a look at all of them. So one, there is food. Basically, last time I checked, there's not a lot of plants on Mars that we could eat. Then the second big problem is the temperature. It can reach up to minus 125 degrees Celsius, which is really way too cold for humans. But maybe it is the lacking of liquid water through which, because of which plants can't really naturally grow on the Mars surface. Maybe it's the oxygen that really isn't common in its atmosphere. Or maybe it's the atmosphere itself with only a density of about 0.6% compared to that of Earth. That means basically the pressure on Mars is less than 1/100th than here on Earth. That is a big problem. But maybe it's radiation. The Mars's radiation can be about 100 times larger than here on Earth, which might give astronauts cancer. So now I'll propose a small solution for everyone, and then I'll choose which one I think is the largest. So, for food, you can in theory genetically modify a bacteria such that it is one, edible by humans, two, it should, well, of course, thrive on the Mars' surface, three, it should produce great soil and fertilizer for future growing plants, and four, I think, it should produce oxygen from the CO2 in the Mars' atmosphere. I mean, of course, making a bacteria like that will take a lot of time and work, but it's possible with a lot of supercomputers. Now let's go over problem number two, temperature. Well, basically we could, if we pump up the atmosphere, the temperature problem kind of goes away if we use a lot of gases like methane, which heat the atmosphere up really much. And then a small solution for problem number three, water, is, well, fairly simple because the Mars literally has polar ice caps. So yeah, the problem is it's not liquid, but it will probably turn liquid as soon as the temperature heats up enough. And trust me, there's enough water for the whole Mars. So, and then the next problem is oxygen, but as I've already said, the genetically modified bacteria should be able to produce the oxygen required for life. And then another problem, the atmosphere. Well, we'll get that pumped up, as I've already said, with like methane or something like that. And then the last problem is radiation. The thing is, the radiation is basically the universe's wrath trying to give you cancer and kill you in every way possible. 80% of radiation is caused by supernovae, massive explosions in the universe that's caused by collapsing stars. So basically, they have really much energy. And if this radiation hits you, it's able to deform DNA and with this cause cancer. Now, what should we do against this? Maybe we could take a little lead sheet, which is then to cover the astronauts' skin and body. But that doesn't kind of work out, because if one really high energy particle hits something that blocks it, like lead for example, this one, that's a big problem, turns into a lot of smaller problems. So yeah, you would need a really thick lead sheet to cover up all of them, because the radiation is going really fast, like light speed fast. So now, what could we do against the radiation? Well, probably you already know what is the biggest problem for me. It is radiation. So now, what could we do about it? The reason we on Earth don't have a lot of radiation, because if this is Earth, it has a huge magnetic field around it, which means that the universe's wrath descending upon us can't reach until here, the surface. So now, why doesn't Mars have this? It's because on the Earth, the magnetic field comes from the molten inner iron core, long sentence, of the Earth. But Mars's inner core has cooled out, which means that there's basically no virtual magnetic field on Mars. So now we could, in theory, make one with an electromagnet. And I actually calculated how much power that would take. For the wire in my calculations, I used an alloy that's called the supermalloy. That's because it turns electrical energy really well into magnetical energy. Well, that doesn't make any sense, but okay. It's 79% nickel, 16% iron, and 5% molybdenum. So what I used is a wire which has a radius of about 1 meter. So the diameter would be, well, 2 meters, pretty large. And I just calculated the resistance and such with nickel because laziness and such. So I calculated the strength that we would need of the magnetic field if the wire went around the whole Mars 100 times, okay? And what I got was this. So first off, all of the wire would weigh almost 700,000 tons, which is a lot, but like compared to the Earth, how much nickel the Earth has, it's like not really that much. But nickel is hard to extract and get, so the production of this nickel would be pretty pricey. So, and what I got was this, we would need a current. By the way, all of the wire that went 100 times around the Mars would only have a resistance of about 45 ohms. Yeah, I don't get it how this can be so low, but like you have to think that this is a pretty big wire, like really fucking big. So now what I got was this. You would need about, wait, let me read this. You would need about, listen to this, 1,653,529,000. No, I'm sorry, I'm wrong. Wait, let me say it again. Wait. Okay, yes. 1,653,529,761,000 amps. And now you multiply that with the resistance, about 45 ohms, and you get 7,209,390,674,000 volts. Now multiply that with each other and you get about, I'm not gonna say the whole number in this one, basically it's then about 1.2 times 10 to the 25 watts. And you might be not able to like imagine a lot under that. So let's compare it to the sun's. The sun's energy is 4 times 10 to the 26. What the f***? What the fuck? So you would need 3% of the whole sun's energy just to get the Mars working magnetosphere so that we don't die of cancer. Well, then the whole Mars would be inhabitable. But yeah, I think this approach is kind of horrible. So now the other approaches, instead of making the whole Mars electromagnetic, kind of I guess, you just make the houses electromagnetic. And now I will calculate the houses. So now assuming a house which has a radius of about 30 meters, which is a half sphere, sorry. And it has, again, wire wrapped 100 times around it. with it again being nickel and having a radius of about 2 centimeters, which is about this thick. This is the diameter. Yeah, about pretty thick wires. I calculated it again and I came to 1 exaamp, which is this number. Yeah, I'm starting to think my calculations were wrong. Oh, this is not funny. I spent so much time. Yeah, well, I guess you learned something, which is don't hire me if you want me to calculate something. Yeah, to be honest, I have no interest in calculating that again because I spent the whole day in calculating this. Yeah, this is really weird. Please tell me this is a physicist in you.
Yo, that came out wrong. I'm sorry. I meant a physicist in you, as in the audience. Is the physicist in the audience? That's what I meant.
Which can write in the comments whether I'm of course I'm wrong, but how wrong I am, or rather, what is the correct answer? Anyway, no matter that, I guess you can imagine building an electromagnet which magnetizes the Mars so much that basically radiation doesn't hit you. It still takes an extreme amount of energy. But I'm sorry, I wasn't able to calculate this. Yeah, well, I guess bye now.